This lecture is very important, particularly for the later unit, modeling of control systems. There are not much topics in that unit. Majorly you will be using the topics of first unit in that unit also. For example, try to imagine a question which considers a mechanical system and you have to use Newton's law of motion for finding the equations. Then obviously, after finding the equations, you have to first recognize whether these equations are linear time invariant or not. Since transfer function approach is easier than state space variable approach, we always prefer to use the transfer function approach, but the conditions may not be in our favor. It may be possible that the equations which we have derived for a system are not of LTI system, or maybe initial state conditions of the system may not be zero. In that case, you are forced to use the state space variable approach. That's why you should cover the topics related to transfer function approach first, then cover the state space variable approach, then only after completing all the topics, you should cover the unit modeling of control systems, so that you will be having the idea of all the concepts which you can use in modeling or solving control system of real life scenarios. Well, try to be focused for this lecture as it is going to play a very important role in solving various numerical problems, not only for this unit but in the later units also. Our first topic will be how to convert a block diagram into signal flow graph. First consider a block diagram, then input node, output node, and all the takeoff and summing points are converted into nodes. It is not a very difficult thing to convert a block diagram into signal flow graph. There is only one point regarding this topic which you have to remember always. Suppose that we are having summing point before a takeoff point. In that case, you can merge the summing point and takeoff point into a single node. But if the scenario is opposite, like the takeoff point is before the summing point, then you have to convert this takeoff point and summing point into two separate nodes. As T, which is exactly in the order of English alphabets, if the summing point and takeoff point lies in the same order, then you can merge. But if these are in opposite order, then you cannot merge these points into a single node. If by any chance you are not able to recall this point, then in the examination, you should take the summing point and takeoff point into two separate nodes, because it is actually a simplification factor. It does not mean that in the case 1, if you are merging the summing and takeoff point or not merging, the answer will become wrong. It is not like that. It is just a way of simplifying the diagram. If in both the cases you are treating summing point and takeoff point into two separate nodes, then it is not a problem. However, in the case 2, if you are treating takeoff point and summing point into a single node, then definitely your answer will come wrong. Now let's see how to construct a signal flow graph from a real system. First, you are supposed to write all the system equations in the form where all the variables are clearly specified. In this representation, x1, x2, xm all are variables. The equation for input node is actually not required in most of the cases. The step 2 will be you have to arrange the different nodes from left to right. The nodes may be rearranged, and the arrangement of the nodes should be in a way such that the final signal flow graph is pictorially simple and does not look complex to solve. Afterwards, you have to connect the different nodes by appropriate gains, which are A11, A12, A22, etc. If the output node has outgoing branches, then you have to add a dummy node and a unity gain branch. This point we have already discussed in the previous lecture, where it was an advice for you that if the output node is having any outgoing branches, then try to add a dummy node, and by doing that, the chances of committing mistakes becomes significantly less. Again, observe the signal flow graph carefully, and if there is a need to rearrange the nodes or loops in the graph, you should do to achieve maximum pictorial clarity. Now let's see signal flow graph algebra, which is another very important topic which you have to use for constructing a signal flow graph from a real system. The shown graph is actually a small part of a complete signal flow graph. We have to focus only on 5 nodes, which are A, B, X, and C and D. The value of the variable represented by a node is equal to the summation of all the signals entering the node. For example, the node X can be written to be equal to branch gain D multiplied by the signal at node B plus branch gain B multiplied by the signal at node C minus branch gain G multiplied by the signal present at node A. This point is actually the most important point of the topic signal flow graph algebra. The value of the variable being represented by a node is transmitted through all branches leaving the node. These 2 points you already know, but still I will discuss. Parallel branches in the same direction connecting 2 nodes can be replaced by a single branch with gain equal to the sum of the gains of the parallel branches. And if you find a series connection of branches with the arrows pointing in the same direction, then those 2 branches can be replaced by a single branch with gain equal to the product of the branch gains. By using the signal flow graph algebra and the steps which we discussed just before that, you are supposed to construct signal flow graph or block diagrams of real life systems. It may be possible you may have still confusion. Let's see a real life system and try to make a signal flow graph of it. I have taken an electrical network which is having 3 voltage parameters V1, V2 and V3, 2 current parameters I1 and I2 and 4 resistances R1, R2, R3 and R4. By using simple network theorems like Kirchhoff's voltage law, Kirchhoff's current law, you can write these 4 equations for this network. Now try to think yourself how many variable parameters are there. In total, we are having 9 parameters, 4 resistances, 2 current and 3 voltage parameters. But the question is how many of them are variable parameters. In this network you can see we are having one variable thing which is the voltage source V1. But if we are going to change the value of voltage V1, all the voltage parameters along with current will change. However, there will be no change in resistances. So definitely resistances are not variable parameters and all the other remaining 5 parameters are variables. So at least we have to draw 5 nodes to make our signal flow graph of this network. Let's take 5 nodes. We are going to take it slow and try to understand it step by step. Now I have named these nodes also, but it is actually very important that how you are going to name these nodes. If you are naming differently, then it may be possible that your final signal flow graph will be very complicated. As a general rule, you should name your nodes in the same manner as they are introduced from left to right in the network. Once again see the network clearly. In the leftmost side, we are seeing V1, then I1 is introduced, then the voltage parameter V2 is present, then comes I2 and then finally comes V3. And I have arranged these nodes in exactly the same manner as they are introduced from left to right in the electrical network. It is not a rule, but it is advisable to name the nodes like this only. Now consider the first equation. Here you have to use the signal flow graph algebra. You can see I1 is equal to 1 upon R1 multiplied by V1 minus 1 upon R1 multiplied by voltage parameter V2. So from the signal flow graph algebra we know that the signal at any node is equal to the summation of all the incoming branches multiplied by the branch gains. So one thing is for sure, at least one incoming branch from both the nodes V2 and V1 has to be present at node I1, which I have done already. Now next part will be to assign the branch gains. That is also very simple. It is written in the equation itself. I hope till now everything is clear to you, because the things which you have to understand lies up to here only. Afterwards I am going to repeat the things which I have done already. I hope it is clear to you. Let's move to the next equation. V2 is equal to R3 I1 minus R3 I2. Again you are supposed to use the signal flow graph algebra, and particularly the first point which you saw there. You see the node V2 is equal to the summation of 2 different nodes, and for the same reason you have to draw 2 branches coming from the node I1 and I2 merging into the node V2. You have to be very careful about the direction of the arrows also. Even a slight mistake will change your complete signal flow graph and you will definitely get the wrong answer. Now you should pause the video and try to solve the next 2 equations yourself. Don't watch this lecture as if a movie is going on. Take a pen and paper and try to draw the remaining signal flow graph. After solving third and fourth equation, you will be getting this signal flow graph. I have taught you multiple times already that if there is any outgoing branch which is present at the output node, then you should add a dummy node by using a unity gain branch. Here in our case also, you can see there is an outgoing branch at the node V3 which is our output node. So it is recommended to add another node V4 by using unity grain branch. Also, even though it will not affect much in the result, but still it will look more clear if you rearrange this signal flow graph such that all the branches which are in the same direction lies in the same line only. Like if we arrange the two branches which are present in two different red dashed ellipses, then it will look much better. After introducing all the modifications, this is our final signal flow graph for the considered electrical network. This unit is finished here. I hope each and everything is clear to you. This subject as a whole is very easy. So far, if you find any topic difficult, then it is my fault, or maybe my way of teaching is not appropriate for you. In that case, I strongly recommend to look for another teacher and leave my lectures immediately. I have tried my best to make it as simple as possible, but again, it is not like my way of teaching will be preferred by all. I have covered all the theoretical points, but the topics regarding the MATLAB are remaining. I actually have fair idea about the topics of the MATLAB considering the control systems, but the only thing is I cannot afford it. As a matter of fact, I have used only free sources for creating my lectures. Well, anyways, sorry for that. I cannot teach you the concepts of MATLAB, but other than that, I have covered almost all the theoretical topics of the first unit of the control systems. For your help, I have attached short notes in the video description. You must go through them as you may find few points in short notes which are not present in the lectures. Best of luck for your preparation. See you in the next lecture.